Lab. My name is Jessica Orvis, and I'm going to be giving you a few pointers on these labs as we go along. And this week's lab is limiting reagents. We're going to be looking at this reaction of barium chloride and sodium sulfate. This is a double displacement reaction, so the cation of one reacts with the anion of the other to make barium sulfate and 2 sodium chlorides. Now, we're starting with a solid mixture of barium chloride and sodium sulfate. Both of those are soluble in water, but the mixture you're starting with is not in water yet, so it's a solid mixture of these two. You are going to add the water to it, so these dissolve, they react, barium sulfate is your solid, and sodium chloride will be dissolved. But in this particular setup, you're going to have more of one of these solids than you do the other. And the one that you use up first, of course, is your limiting reagent, and the one that's left over will be in excess. So what you're going to want to do is set up a boiling water bath and get a test tube of this with a required amount of unknown in it. You're going to run 2 trials of it. You can run both of those at one time. You're going to set it up and have that ready to go. You are going to take, after it is heated for the requisite amount of time, you're going to filter it to get your solid barium sulfate, and you need to be sure to save the filtrate, that liquid that comes out on the other side. That has dissolved ions of sodium chloride and the dissolved ions of the reagent that you have in excess. So you need to hold on to that. You're going to take the solid barium sulfate, dry it, and weigh it. Then you're going to take that filtrate and test it to determine which ions are in that filtrate that indicates your excess reagent. There will be bottles at the front of the lab of dissolved barium chloride and dissolved sodium sulfate, and you'll need to think about this a bit. Which one of these do you want to add to the filtrate in order to see whether or not you get the solid to form, and what does that mean? I recommend that you take that filtrate and pour it into several different test tubes. Sometimes you can see a positive result in one that you might not see in the other, and it's just a good idea to have separate samples of this so that you can test it again to be sure. But the idea is this: if barium chloride is in excess, then you will have extra barium ions in your filtrate, so that when you add sodium sulfate to it, you should see a solid form. That would be an indication that barium chloride is in excess and sodium sulfate is your limiting reagent. Of course, everything is reversed if the opposite happens. After you identify which reagent is your limiting reagent, then you're ready to do the calculations. You start with that mass of barium sulfate that you know, you weighed it out, and you know how to convert that to moles of barium sulfate. And using the stoichiometry of the reaction, the mole tunnel, you can convert that to moles of your limiting reagent. And you know which one that is, one or the other, and you could convert that to grams of limiting reagent. But that is also equal to moles of the other reagent that reacts. In the world of the excess reagent, some of it is reacting and some of it is not. Right? So for the, let's look at mass of excess reagent. It's equal to the mass of excess that reacts plus the mass of the excess that is unreacted. So if you take moles of limiting reagent and convert it to moles of excess reagent, that is the moles of excess reagent that reacts. And